Hello, everyone. This is Don broadcasting live from my science loft full of books that aren't all science. In fact, they're mostly fiction. But today we're in the science loft because it's a really good place to demonstrate the principles of static electricity. I know last week's video was something you couldn't easily do at home. So this week I decided to do something that's really, really easy to do at home. All you really need for the basic version of this is a balloon or three. Now, before I demonstrate what we're going to be doing, I want to talk about what static electricity is. You probably all experienced it. If you take something out of the dryer and it sticks and it pops and it hisses when you try to put it on, and you get all that weird static cling feeling. Or, maybe you are walking around on a cold, dry winter day and you get all charged up and you touch a doorknob and get a bit of a shock. That's all static electricity. And balloons are very good at static electricity. What it really comes down to is the structure of matter. All matter is made of tiny pieces called atoms, and atoms are made of even smaller pieces called protons, neutrons, and electrons. Now, an atom has a nucleus. It's the very middle center part of the atom. We're going to pretend that this balloon is the nucleus. The nucleus holds the protons and the neutrons, and then I'm going to blow up a smaller balloon. Hold on. There we go. And this balloon is going to represent electrons. Protons, neutrons, and electrons. Electrons orbit around the nucleus. And it's kind of helpful to think of the electrons as like planets orbiting a sun. It's not 100% accurate because quantum physics is really weird. But the upshot is that they're out here and the protons and neutrons are in here. Now, all these particles they're not all charged. Neutrons aren't charged. They're neutral. Protons, however, have a positive charge. Electrons, much smaller, have a negative charge. And because they are outside the nucleus, it's easy sometimes for them to get pulled off of atoms that make up different substances and stuck to other things. And when that happens, you get a static charge. The object that loses electrons lost some negatives, so it has a slightly positive charge, and the object that gained electrons gained some negatives, so it now has a slightly negative charge. What this means is if you use a little bit of friction to rub electrons from one surface to another, you can use the fact that opposite charges attract and like charges repel to do some interesting stuff. Now, I'm going to move over here because there's a wall and I want to use it. You may need to do this with an old washcloth. I'm going to do something different with an old washcloth here in a second. But I have found it's actually really easy for me to do this just by rubbing it on my head. Get a good static charge. You can feel it crackling, and then see if it works. Ta-da! Stuck right to the wall. Because if the surface that you're touching the balloon to has an even slightly different opposite charge, those charges are going to get attracted to each other, and it's going to seem to defy gravity. That's the easy version of this. Now, if you're just tuning in, we're talking about static electricity today, when electrons get rubbed off from one object onto another and give each of them an opposite charge, an equal and opposite charge. And I just managed to charge up this balloon by rubbing it on my head, stealing some electrons from my hair or giving some electrons to my hair. I'm honestly not sure which. And then sticking it to the wall. Oh, a little weak that time. That's okay. But you can tell it's slowed down from how it would have fallen normally. Now, the advanced version of this, instead of using opposite charges to repel or to attract, you can use like charges to repel. And for those charges, I'm going to need this science bindle stick I made. It has everything I'm going to need. We're going to need this PVC pipe. We're going to need the rag, the old dishcloth here. And we're going to need this plastic thing I have. I'll explain more about this in a minute. And if you have some of these packing peanuts, these are really good too. Okay, so let's charge this balloon up again. Here we go. Ta-da. Styrofoam's really good at holding a charge too. Let's see, can we get two? Can we get two? No. Can we get two over here? No. There we go. So they're just sticking there because we have opposite charges. They have a little bit of static, or the balloon has a little bit of static that's attracting the styrofoam. Okay. But like I said, using like charges to repel, that's the real trick. So this is a ring of plastic. I just cut it off the top of one of those produce bags you can get at the grocery store, you know, like you put your onions in it. Just cut the top right off of it. Now I'm going to charge this up by rubbing it on my head. Oh, you can tell it's charged because it's sticking. I'm going to store it over here on this wall. Okay, you can't see it, but it's sticking to the wall, just like the balloon did earlier. And now, I can't really rub this pipe on my head. I mean, I could, but it would take forever. So I'm going to charge this up statically by rubbing it with this rag. I don't know if you can hear. Let me put it up really close, but it's crackling. I can hear and feel the static buildup on it. Let's see if I can get this to work. It was working yesterday, but it's a little touch and go all the time. Now, these both have the same charge, which means, in theory, they should repel each other. Okay, hold on. Try this one more time. Need more charge. I know, I look silly. Deal with it. There we go. So both of these either have some extra electrons, or some extra protons because they gave up electrons. I'm not sure which, it's hard to tell. But either way, they have the same charge. They're either both positive or they're both negative. Oh, see, this must have discharged a little bit. Now, because I am the opposite charge, how do I know? Because I'm either giving or taking electrons from this plastic ring. That thing is attracted to me. And you may have seen that when I screamed, no, and spun around, it's because it was coming towards me. The attraction to me momentarily overcame the repulsion from the PVC. There we go. But for a second before then, we had a good static levitation going. Just using some of the invisible forces of the universe to make something look magic. It's not magic. It's just science. And all you need, if you happen to have a PVC pipe and a rag and an old produce bag, you too can make stuff levitate. Now I'm going to do one last trick. And I have a volunteer. It's over there. His name is Dean. And Dean is a very calm cat. So he'll let me do this and I won't bother him too much. This is not really... I'm not going to teach you a heck of a lot, but it's kind of fun. It's not going to bother the cat very much. I'm not going to leave it on for too long. If you don't know what I'm getting at, just wait. I'm going to use the small electron balloon here. Hi, Dean. There he is. He has no idea what's coming. Charge it up. Charge it up. Yes, it's stuck to you. Let's see. Yesterday he got up and moved. Today he's just a little confused. I don't think he likes the balloon very much. Let me try the big one. Now, if you have an exceptionally cranky cat, I do have a couple of those. Oh, look, you can watch. Can you see that? Let me get really close. His fur is actually getting attracted to the balloon. I don't know if you can see that at all, but I can see it from here. It's pulling up as the balloon gets closer to him. And then we stick it on. Maybe we put this one over here. Okay, Dean, thank you very much. You were a good volunteer. Anyway, as I was saying, if you have an exceptionally cranky cat, you may not want to bother them with that. In any case, you don't want to bother them for a terribly long time because, you know, they're just doing their thing. It should work with dogs too. I don't know why it wouldn't. Maybe they have slightly more oily fur because they don't clean themselves as often as cats. Maybe it won't work, but hey, give it a try. You never know. Or, can I get sick to myself? Nope. Yeah, that's because we have opposite charges, right? But, you know, using static electricity, you can do some pretty neat stuff. And it's all about losing electrons or gaining electrons to create electrical charges, either positive or negative. And all you need, tried to make this one simple, is a balloon. Thanks for watching, everybody. If you come up with any cool ways to use static electricity with a balloon and maybe a cat or 2 or 3, yeah, that's Castiel. He's confused too. He's perpetually confused. You can post it on our Facebook page or on our Twitter. Just make sure to hashtag it TCM at home, hashtag TCM at home. Thanks for watching, everyone, and I'll see you the same time, same place, for me anyway, next week. Bye.